the last lectures we studied when the shear force diagram given, draw load diagram, and after that draw bending moment diagrams. So today we will see when the bending moment diagrams given, draw load diagrams and draw shear force diagrams. So first, according to the given bending moment diagrams, draw load diagrams and shear force diagrams. So please note down today's first problem. Bending moment diagram for a beam as shown in figure.
Bending moment diagram as shown in figure.
Draw load diagram and
draw load diagram and shear force diagram.
Distance 2.5, 2.5,
1 meter. .5 meter, 2.5 meter, 1 meter. $25 kilonewton meter. Mark this point as A point, B point, C and D point. So for such type of the diagrams, so draw first. This is 2.5 meter, 2.5 meter. This is 1 meter, and here force acting, that assume all forces are W1, W2, W3 and W4. Now, bending moment at A point equal to,
in this diagrams,
0. So that's why forget that. Bending moment at B point equal to 25 equal to, so this force multiplied by distance, and this is anti-clockwise, that's why 2.5 or W1 into 2.5. So that's why W1 equal to negative 2.5 kilonewtons. So we'll see its directions, but this sign we got negative. Next, bending moment at C point, this is equal to bending moment at C point here minus 25, and this is equal to W1 into 2.5 plus 2.5 plus W2 into 2.5. 25 W1 equal to 2.5 multiplied by 5 plus W2 into 2.5. This is 12.5 negative, and this is 25 So this is 12.5 W2 into 2.5, because this 12.5 comes in the left hand side and this becomes 12.5. So W2 equal to so what we assume that is correct now, right. Oh, we consider this because this is minus and this is also minus because this moment is the anti-clockwise. So that's why this becomes plus and this is minus. My answer is 30 kilonewton. W1 equal to, we did mistake here. This is actually 10. So that's why this is 10 and this is plus 50. So that's why this becomes minus 75 and this is 2.5 means W2 equal to 30 kilonewton. All right, this is correct. Next, bending moment at D point equal to D point 0. Now moments W1 2.5 plus 2.5 plus this 1 meter minus W2 2.5. Okay, plus 1 and third moment W3 into 1. Now put 0 W1 equal to minus 10 into 6 kilonewton (3.5 kilonewton) and W2 equal to how much? This is 30 minus W3. This becomes 60 plus 60 minus 70, 30 into, okay, 105 W3. (45 W3) or W3 equal to minus 45 kilonewton. Now for equilibrium condition, and W1 plus W2 plus W3 plus W4 equal to 0. minus 10 plus 30 and this W3 minus 45 plus W4 equal to 0. This is 20 and W4 equal to 25 kilonewton. Right? So that's why here negative sign indicates our assumption was wrong. So change sign negative to positive. So here, so we assume this is downward, and water may be the, because W2, this is 30 kilonewtons, this is final. So we have to change this sign. So that's why load diagram. Now this is 10 kilonewton. We have to change. This is positive. Change the direction. So 10 kilonewton upwards, 30 kilonewtons downward means that is correct. So that's why this is 30 kilonewton downward. This is distance 2.5, A, B, C and D point. At C point 45, so that's why we have to change this direction, 45 kilonewton upwards, and W4 this is 25, so that's why this is 25 kilonewton. Right, 10 plus 55, this is 55. This is your bending moment calculations. Now shear force diagrams. So directly you can draw shear force diagrams, because this is 10 kilonewton, A point, B point, this is C point, D point, 30 kilonewton, sorry, this is 10, this is 10, so that's why this is 20. In between B to C, no force. At C, this is 25 kilonewton. So this is your shear force diagram. This is your shear force diagram, and this is load diagram. Now I think you understand how to solve the problems when the bending moment diagrams is given. Now next, so in these problems, this is positive and this is negative. Now when this is negative and this is positive, so again similar type, but here only 3 point. A point, B point, C point. 3 meter, 3 meter. So in this case, here, because bending moment at B point, that is changed. So it is intensity given 6 kilonewton, 6 kilonewton meter. This is 6 kilonewton meter. This is also 6 kilonewton meter. So that's why here consider 3 forces. One W1, second W2, W3, distance 3 meter, this is 3 meter, couple acting, so that we can consider this is clockwise. Now, bending moment and this point, A point, at A equal to, this is 0, bending moment just left hand side of B point, just left hand side of the B point, this is -6 equal to W1 into 3. So W1 equal to minus W1 kilo Newton. Now bending moment just right hand side of B point, this is plus 6 W1 into 3 and this is plus m. Now 6 minus 2 into 3, 6, this is m equal to 12 and this is we assume this is clockwise and this is clockwise. Next, bending moment at C point, this is equal to 0. Now force W1 into 3 plus 3 and okay. I think I did a mistake here because this is anti-clockwise. This is plus because anti-clockwise. Again, this is anti-clockwise. This becomes -6 means right. Now this is 3 minus W2 into 3 and this is plus m equal to 6, 9. Right, W1 minus 6 minus 3 W2 plus 12. Minus 6 into 2, 3W2 plus 12. This is 12 minus 3W2. So this will get cancelled. W2 equal to 0. And for equilibrium condition, the sum of the W1 plus W2 plus W3, this is equal to 0. W1 equal to plus 2, W2 0 plus W3. So that's why W3 equal to minus 2 kilonewton. Now this negative sign change. Negative sign is to be indicate direction assumed is wrong, change direction. So that's why A point, B point, C point, W1 equal to plus 2 kilonewton. Right. Plus 2 kilonewton. At B points, no. This is couple acting, 12 kilonewton meter, and at C point, this is negative. So that's why we have to change. This is positive. So this is your load diagram. Now for shear force diagram, A point 2 kilonewtons downward, A to B, okay, at B point so again there is no any force, so that's why this is your shear force diagram. Right, this is 3 meter and this is 3 meter. And this is negative shear force diagram because this is positive and this is negative, because there is no any indications about the movement in the shear force diagrams. Right, and this is correct. Next problem, this is today's third problem. Two meter, 2 meter, 2 meter, 2 meter, 2 meter, and 12, 12, 12. 12. This is 12. Mark this point A, B, C, D and E. So this is third problem. So you have 5 points, means we require more space. So again, you have 5 points, so that's why better. Okay, and here couple actings at B point, so that's why this is also assumed clockwise, right? Next, bending moment at A equal to 0. Bending moment at B, just left hand side. Just left hand side of B. This is plus 12 equal to minus W1 into 2. So W1 equal to 6 kilonewton. Anti-clockwise, this is plus, so that's why this is minus. I will check my answer. Right. Next, bending moment at just right hand side of B point. This is equal to minus 12 W1 into 2, right? So that's why plus, and this is moment acting, minus 12 into minus 6 into 2 plus m, minus 12, this is plus 12, 24 m, and this is minus, so we have to change this sign. So here this is change direction, here also change direction of movement, and here directions of force. instead of the downwards, we have to assume this is upward, and instead of the this is clockwise, this moment is the anti-clockwise. Bending moment at C point equal to 0 minus W1 into 2 plus 2 plus, this is again minus, because this is anti-clockwise, W2 into 2 plus, because this is clockwise, M equal to 0 W1 minus 6 into 4 W2 plus M equal to minus 24. This is plus 24 minus 2 W2, and this minus 24. This will get cancelled. W2 equal to 0. Bending moment at D point, this is equal to minus 12 minus W1, increase distance 2 plus 2 plus 2 minus W2 2 plus 2 plus M minus W3, this is minus W3 into 2 minus 6 into 6 4 plus M, this is minus 24 36 4 W2 24 to W3, right? 4 W2, so this is multiplied by 0. And this is minus 12, this is 12 to W3, and it's minus 24, is W3 equal to 12 kilonewton. Right. So bending moment at E point. Next moment is change direction. So that's why here I use this space. Bending moment or MD equal to 0. Now MD, this is 12, it's not 0, 12, W1 into 2 plus 2 plus 2 plus 2, okay, oh, we already calculated this, so this is 0. Next, minus W2 2 plus 2 plus 2 plus M plus minus W3 into 4 W4 into 2 W1 equal to minus 6 into 8 0 into 6 This is minus 24 12 into 4 minus 2 W4, and this is equal to 0, 48, 0, 24 minus 48. Okay. So this is getting more value. This is minus 6 into minus 6. So this becomes 48. This will get cancelled, and this is 24 equal to W4 equal to minus 12. Right. Now equilibrium conditions: W1 plus W2 plus W3 plus W4 equal to 0 and W5. W1 minus 6, W2 0, W3 plus 12, W4 minus 12, W5 equal to 0. This plus 12 minus 12 will get cancelled, and W5 equal to 6 kilo Newton. Now you can draw. This is 6 kilonewton, so that's why we have to change this direction. 6 kilonewton. Second, 24. We assume this is anti-clockwise, so that's why we have to change this sign. 24. And W2 equal to 0, so no force acting. W3 12 kilonewton. W4 equal to 12 kilonewtons, and this is upward because this is minus, and W5 equal to, this is plus 6 kilonewton. Now you can erase this and draw. So I will check. Right. So this is 2 meter, 2 meter, 2 meter, 2 meter, A point, B, C, D and E point. Now draw load diagram. This is upward 6 kilonewton, in between up to this point 6 kilonewton, A point, B, C, D and E. This is 6 kilonewton. (12 kilonewton downward, 6 kilonewton, and this is 6 kilonewton. This is your shear force diagram. So this is your shear force diagrams. So today, because of the I completed all types of other problems, but some of the problems means that is the conditions when the unknown load is acting. So how we can calculate? That's why again I will engage one class or 3-4 classes, means that is for simply supported beam or for cantilever beams, etc. I will engage. So after that we can start the 4th unit, that is the shearing stresses and bending stress. So that's why today I stop here. Thank you.